So we're taking a look at the PIPO, or parallel in, parallel out register. So what we've got is we've got an input that is parallel. In this case, it's 4 bits. And so let's say you want to do the sequence 1, 0, 1, 1. Note that this is the most significant bit and this is the least significant bit, which is kind of what you might expect. But with some of these flip-flop devices, it's not always what you might expect. So make sure you pay careful attention to the labeling when you're looking at things like this. And so we see that the output hasn't changed yet, and that's because these D flip-flops need a positive edge clock pulse before the output changes. So we give it that positive edge, and there we go. We got 1, 0, 1, 1. And now this number is kind of captured in here, and it can be accessed in a parallel fashion. And so I can't remember if I addressed this, but I'm going to address it again. You might say, well, hey, maybe I know a little bit about electronics. I know that clocks normally, they just go at a constant frequency. They're always going. So doesn't that just mean that this is constantly going like this, constantly just going? And so that means we'd have to constantly rewrite it if we wanted to keep that in there. Well, it is true that clocks do usually constantly pulse. The actual input to the device doesn't need to be pulsed. There might be some other circuitry in here that enables one register versus another register. So perhaps there's like an AND gate, and when that one of the signals to the AND gate is a 1, then the clock can come through. Otherwise, you might be writing something else that are connected to these same 4 wires. So this clock, even though the system clock might be clicking a lot, the actual input to the register isn't clicking as frequently. Just something I wanted to add in on this video.